So in this video, I want to talk about the relationship between Verilog and SystemVerilog, and later on, I'm going to show you the differences in terms of code. So Verilog was introduced or developed in the 80s along with VHDL. However, it wasn't basically a standard. So later on, it was put into a standard called IEEE 1364, and you can still look at the documentation to see it. And that standard was only ratified in 1995. Okay. Then a few years later, say about 6 years, there was major revisions to this version of Verilog, and that's basically Verilog 2001. Chances are this is what you have used in the previous course in Verilog. A lot of people still use Verilog 2001 if you're using Verilog, not SystemVerilog. So in 2001, the IEEE standard was still 1364, but it was version of 2001, so it's called Verilog 2001. However, this particular Verilog version did not have any advanced verification features. For example, you can write test benches, but they weren't sophisticated enough. So later in 2005, what happened is there were some minor revisions to the language, which is Verilog 2005. Some people still use it. However, the vast majority of people in industry, the one I've seen, is actually they still use, if they're using Verilog, not SystemVerilog, they're still using the 2001. Very few use the 2005. But more importantly, in 2005, there was another IEEE standard, and it's called IEEE 1800. And that IEEE 1800 introduced SystemVerilog 2005. SystemVerilog was introduced as a verification language. It wasn't meant to be as Verilog, as a description language that you write code and it describes hardware. It was meant to associate Verilog or to go hand in hand with Verilog and actually do some verification on the code or the description you did in Verilog. Later on in 2009, what happened is it got a little bit confusing. So what happened is they merged both standards 1364 and IEEE 1800 into IEEE 1800, and they made SystemVerilog the official language that actually has verification and synthesis together. So Verilog stopped to exist after 2009. You still write Verilog, and if you're writing Verilog, chances are you're writing Verilog 2001 or Verilog 2005. Most likely it's 2001. Now, in this course, what I want to do is we want to basically use SystemVerilog only, and we're going to be using it for synthesis. We're not going to be delving too deep into SystemVerilog and its advanced feature. It has object-oriented features and whatnot. We're not going to be doing any of that. What I want to use SystemVerilog, and specifically here's some particular interesting graph from the book I'm using, and that book tells you, okay, SystemVerilog is a massive language, and SystemVerilog is actually, by the way, backward compatible with Verilog. So the old Verilog code you actually wrote, it still works under SystemVerilog. You can just plug it into your code and it still works. It's backward compatible. It can go all the way to 2001. However, now because the SystemVerilog is backward compatible and whatnot, you're going to see that Verilog is a subset of it. However, that subset of Verilog is not completely synthesizable. So there's part of Verilog that you can write that you cannot actually put onto hardware. What we will focus in this course is actually as a subset of actual Verilog and SystemVerilog that is synthesizable. So it's going to be mainly Verilog, and I'm going to introduce a little bit of features from SystemVerilog. So whatever you have learned, you're going to still use. However, I'm going to use the improvement that got introduced in SystemVerilog. But anyway, in any case, what you're going to see, I'm not using everything in here. What I'm using is actually a very small subset of it that is synthesizable. So this is just a synthesizable subset of SystemVerilog. We're not going to be using all of the features. You're going to see that there's a bunch of things that we're not going to be using. Okay, we're going to be using a very small subset. Again, this course is not a Verilog or a SystemVerilog focused course. We're not going to be focusing on the language. We're focusing on how do we develop and implement digital systems and actually software systems and a software hardware co-design.